Assalamu alaikum. So today we are going to be looking at how do we evaluate our algorithms for NLP that we develop for NLP. How do we say, okay, bhai, this implementation that I've developed is this good? Okay? So we are going to be looking at evaluation metrics today. So let me share my screen. Okay? So today's topic again is about evaluating or rather than evaluation metrics. Okay. So most of the algorithms that we have seen up till now are classifiers. So evaluation of text classifiers can be done using some set scores such as F1 score, precision, recall, and such. Okay. And then there are other algorithms like summarization and machine translation that are actually generative algorithms. So for these algorithms, we have other metrics such as the blue score, the ROC score, etc. Okay? So there are many evaluation metrics. So let's start with the evaluation of text classifiers. So for a simple binary classifier, or binary classifier evaluation, we can draw a 2 by 2 contingency table. See? Or also known as the confusion matrix. Okay, so this is how it's drawn. It's a 2 by 2 matrix. So you have the correct samples and you have the not correct samples. So for example, for correct samples, you're saying these are positive samples, and not correct means these are negative sample or not positive samples. Then there is your algorithm that you have developed. So it selects some of the correct samples and some of the not correct samples, or it classifies them as positive. And then there are these not selected items or these samples. Okay? So let's say there are X number of samples. There is a sample that is marked as correct in the test set, and your algorithm also selected as it as correct. So this is a true positive. Similarly, if there is a sample that's marked as not correct in the test set, and your algorithm also says this is not selected, so this is a true negative. Yeah, both of these are correct. Similarly, if let's say in the test set it says this is a correct sample, but your algorithm says this is not correct, so this is a false negative. And similarly, if in the test set the sample is labeled as not correct and your algorithm says this is correct, so this is a false positive. ठीक है? So the simplest metric is accuracy. How many times your algorithm got things right, and over what were the total number of things. So the accuracy would be true positive plus the number of true negative samples divided by all of the samples. So true positive plus true negative plus false positive plus false negative. So this is the accuracy. The thing is, most of the times this is not a very good measure. For example, if the data set is skewed, say, for example, if you have, let's say, 200 million people in Pakistan, and you say, कि भाई, the number of positive corona cases is 4,000. So that's 0.0001. If you say, कि भाई, how many, you develop a system that says, कि भाई, how many people have corona, and that system only does this, that it assigns everybody a negative result that is negative, so that would be 99.9% accurate. So accuracy in that sense is not a very good measure. So what we do is we measure a few things such as precision and recall. So precision deals with true positive and false positive, ठीक है, and says what percentage of selected things are correct. So these are the selected things, true positive and false positive, and that is precision. And there is recall, कि what percentage of correct items have been selected. So these are the correct items, which are true positives and false negatives, and what percentage have been selected. So before I move on, let me show this to you using a figure that I like very much because of how it is. So let me draw this figure. Let's say this is the space of samples. So these are correct samples, and these are not correct samples. And as I said, you can think of correct samples as positive samples and not correct samples as negative samples. And this is what it looks like. So I'll draw these as, say, pluses. And similarly, the not correct samples as these negatives. So let's say you build a classifier that does this. It takes some samples, and this classifier classifies these samples within the circle or within this oval as positive. So these are the selected samples. Right? So in that case, these samples which are labeled positive, and your classifier is also saying that these are positive, these are true positives. Right? Similarly, if your classifier selected some samples which are actually negative, these are false positives. There are some samples which are actually positive, but your classifier did not pick them up. Right? These are false negatives. And there are some samples which are actually negative, and your classifier did not select them and says these are negative. So these are true negatives. So that's where the division is, as I mentioned in the above line. So that means that this is where your classifier is correct and this is where your classifier is correct. And from that measure, the accuracy would be true positive plus 2 negative divided by the total number of samples, which are in this case false negative, all these samples, plus true positive, all these samples, plus false positive, and plus true negative. So that's the total number of samples. Right? So this can be any kinds of text. These can be positive reviews, negative reviews, and that's what you're trying to do. So as I said, there are better metrics such as precision and recall. So precision, I think I should write this down. As I said, okay, what percentage of selected things or samples are actually correct? See? So I'll write it as P and say the percentage of selected things is TP and FP. So the percentage is true positive samples over true positive plus false positive. These are the selected things, and the percentage will give you, okay, these are the samples which are correctly identified from amongst the selected ones. Then similarly, the parallel metric is recall. Recall tries to capture, okay, what percentage of correct samples are selected by your classifier. So in that case, recall can be written as, so these are all the positive samples which are correct. So true positive over false negative plus true positive. So all these amongst the positive ones, what percentage has been captured by your algorithm? See? So that's recall. So let me do an example for you. Let's say there is a new test for the coronavirus, and we want to figure out how accurate is this test. ठीक है? So this new test selects 40 people or 40 patients, sorry, 40 patients out of 10,000. See? And let me draw the confusion matrix. Okay, this is what it looks like. Okay. So these are the correctly identified patients, not correct. Then there's selected by your test and not selected by the test. Okay. So let's say out of the 40, 8 were correctly selected and 32 were not correctly selected. So it selected 40 patients, sorry, 8 correctly and 32 incorrectly. So there are 2 patients who were actually COVID positive, but the test says they are negative. And that leaves us with 90. Okay, I think in my example, there are 100,000 patients. So that leaves us with 99,958. See? So 40 plus 2, and the sum of all these 4 cells would be 100,000. Okay. So the precision would be saying okay, the percentage of selected things that are correct. So precision would be 8 and the selected are 40. 8 plus 32. So that's 8 over 40 and the precision turns out to be 0.2 or 20%. Right? Similarly, recall is looking at the percentage of correct items that are selected, or the recall is saying okay, how many of the truly positive patients have been identified. So that's 8 over 8 plus 2. So that's 8 over 10 or 0.8 or 80%. So the precision of this new test is 20% and recall is 80%. Now the thing is that we would like to have a metric that combines both these. So that brings us to a combined measure, or this is called the F measure. Right? So the F measure is actually a harmonic mean of the two values, which is precision and recall. So that would be alpha 1 over precision plus 1 minus alpha 1 over recall. And that's how the harmonic mean is computed. Okay? So if I convert this alpha into beta, that would become beta square plus 1 precision and recall multiplied together, and beta square precision plus recall. That's the F measure. And most popularly, what we use is called F1 measure. So F1 means the beta value is 1. So that means beta square is 1 plus 1, 2 precision recall multiplied together. And this is a 1, so precision plus recall. Okay. So that's the F1. Similarly, if we had taken F2 measure, which is less commonly used, this would be 2 squared plus 1, 5 precision recall, and 4 times precision plus recall. But generally, what we use is the F1 measure, that's more popular. So in that case, if we were to calculate the F1 measure for this matrix, that would be precision times recall 0.2 times 0.8 divided by and 2 multiplied by this, and 0.2 plus 0.8. So in the numerator it's a 1, sorry, in the denominator. In the numerator, that's 1.6 times 0.2. That's 0.32 and or 32%. Right? So as you can see, okay, what the F1 measure does, it takes an average or a mean of the two values, but it inclines towards the lower value. So the F1 score for this kind of a test that produces these results is 32%. Right? So that's a better metric that combines both precision and recall. For binary classification, similarly, we have for multi-class classification. So as we saw last time, okay, there are some problems in which we have multiple classes. For example, if we have POS tagging implemented as a classification problem, it would have 52 classes, including nouns, pronouns, adjectives, adverbs, and their subcategories. So, how is multi-class classification implemented? Multi-class, if there are multiple classes, we transform the problem to multiple binary classification problems. So let's suppose we are doing uh, POS tagging. What we do is at the root node, we say, okay, is this a noun or is this something else? See? So if it's a noun, it would be classified as such. If it's something else, then we would say, okay, is it a verb or is it something else? And similarly, we keep on doing this. Okay, is it an adjective or something else until we have all the classes. So this is the one versus all strategy. Right? So in this strategy, we train a single classifier for each class. So that means if we have m classes, we have m classifiers. And that would produce a combined confusion matrix. See? So let me draw this as an example. So we would have a large confusion matrix with multiple classes. So we have uh, class 1, class 2, class 3, all the way to class m, and similarly on the y-axis. So class 2 all the way to class m. And then we would have these samples. Let's say we are doing this POS tagging. On the on this, these are actual classes, and these are assigned classes. Okay. So in that case, we'll have values here such as this, which says, okay, actually there are 137 items which belong to class 1 and they're classified as class 1 by the classifier. Say 55 samples of 55 words which were in class 2 and they are also labeled as class 2 by the classifier. And similarly for C of M would have this number. So everything on the diagonal is correct. See? And then there are these wrong ones. So such as this 13, there are 13 items or 13 words. You can say the actual class was C2, but it has been classified as C1 by the classifier and so forth. Okay? We have these numbers, let's say 1, 0, and 3, 0, and so forth. So you have the entire matrix full. Right? So now what do we do? Now the question is, how do we calculate precision and recall in this case? So what is P? So if you recall, P was the true positives over true positives uh, plus the false positives. So let's say we are calculating precision for class 1. See? So what would be the precision for class 1? The precision for class 1 would be, let's say, the sum of C11 divided by all these values in the row. See? So that would be the sum of all the values C of uh, in the first row and J. See, where J goes from 1 to M. So that's for 1. Right? So if I were to convert this to some random class I, the precision for class I, and I'll just write it as precision of I, would be CII divided by the summation of Cij, where j goes from 1 to m. Okay? So that's because precision is calculated this way. Similarly, if you're looking at recall, recall is calculated this way. So recall for class 1 would be in this column. So 1 1, this value, and the sum of everything in the first column. So that would be C of j and 1. So j goes from 1 to m. So which means if I were to generalize the formula for recall, that would be CII divided by the summation of C of ji, where j goes from 1 to m. And I'm shifting the indices so that I don't have to change the formula that much. Okay? So that's precision and recall. Just as a side note, what would be the accuracy? See? So the accuracy would be all of these things in the diagonal combined. So C of i's, where I goes from 1 to m. So there are m values in the diagonal, and divided by the summation of the entire matrix. So that would be a double sum over I and j and Cij. Okay? So that would be the accuracy of the system, of our algorithm. Okay? So now the question is, yeah, how are we going to compute the F measure or F1 score? You know? So what's the F1 score? There are multiple ways of calculating this F1 score. So one of them is called macro averaging, or let's go with micro averaging first. Micro averaging. See, in micro averaging, what you do is collect the classifications for all classes in a combined table. So we have a combined uh, confusion matrix as we had earlier, and then we evaluate. Okay? So collect classifications for all classes in a combined table, and then evaluate. So in that case, the F1 score would be this precision and recall. See? But the precision and recall was not the same for all classes. So uh, we are going to combine the values. So for example, in micro averaging, for the entire table, So we have these correct samples in the table, and we have the values which are not correct. Sure. Okay. Interesting. Okay, I'll because this is confusing, I'm going to go with macro averaging, in which we compute measures for each class separately and then average. So in that case, we are using the same scores. So F1 for class 1 would be the precision for class 1, recall for class 1 multiplied by 2 divided by the precision for class 1 plus the precision for the recall for class, sorry, for the recall for class 1. Okay. And similarly, we have the F1 score for class M. So that would be 2 times precision of class M, recall for class M, as we had computed earlier, the precision for class M and the recall for class M. And once we have measured the F1 scores for all of these, we are going to average them all. So we are going to sum them all up, F1 to I, say where I goes from 1 to M, and then we take the average, and that's macro averaging. Okay. So similarly, in micro averaging, what we are going to do, we are going to calculate the precision and recall separately. So before calculating the F1, we are going to calculate the average precision for all classes. So we take precision of class 1, precision of class 2, all the way to M, and then we sum them all up and we average them. Similarly, recall for class 1, recall for class 2, all the recalls, we'll sum the recalls up and then we are going to average them together, and the averages are going to be combined to get the F1 score. So this is micro averaging. Okay, so that's all I'm going to talk about in terms of the F1 score. And that brings us to blue score. Blue score stands for bilingual evaluation under study. पेन को भी रोजा लगना शुरू हो गया. ठीक है. So generally blue scores are used for machine translation, summarization, and as I said earlier, okay, generative models that are generating text actually use blue scores to evaluate the quality of generated text. ठीक है. So without further ado, let's look at an example, and I'm going to show this to you with an example. So let's say in Urdu, you have this text, Billi sofe par. Right? And then you ask some translators to translate. So let's say these are human translations. So these are your labels, and you have multiple human translations that you need for calculating blue score. Let's say you give it to a friend and say किस तरह से इसको translate करना है, तो उसने कहा कि cat on the couch, जैसे गूगल ट्रांसलेट करता है. दूसरे को दिया तो उसने कहा कि cat on the sofa, सोफे को वैसे ही लिख दिया. ठीक है. And then there is that translation that your machine translation algorithm generates. Let's say it generates a cat on the mat. So this blue score actually uses precision to calculate how good this machine generated translation is. Right? And the precision is calculated in this manner. So the precision is essentially equal to, or it looks at the words in the generated text and sees के कितने words जो generate हुए हैं इस text के अंदर they also appear in the human translations. तो cat appears in this translation, on appears in this translation, B appears in this translation, mat does not appear in this translation. So 3 out of the 4 generated words appear in the translations given by humans. So the precision is 3 by 4. There is a variation of precision called modified precision that actually removes the duplicity. For example, if there are words, so let's say this algorithm had generated a cat on the mat, so there would be 2 does and it would have said कि हाँ the तो exist करता ही है translation में, so let's count it 2 times. So the modified precision would remove the duplicity, duplication, and removes that from the text. So that means that in this case there are no duplications, so modified precision is still the same. However, if the machine translation was, let's take it for example, it was the, and then let's say there are 4 words generated. We were to calculate precision. The precision would say, does the exist in human translations? Yes, 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 yes. So that would be 4 by 4. 4 words generated and 4 of them exist in the translation. So that would be 1. Similarly, modified precision would say कि नहीं, the should not be counted 4 times. It does exist. So 1, the number of words generated is 4, so that's 1 by 4. So that's the modified precision. Again, so the intuition behind calculating the blue score is to see what kind of sequences appear in the machine translation that are also existent in the human translations. Okay? So in that case, precision is the machine translation words appearing in the reference translations. So these human translations are also known as reference translations. So right now we have calculated precision that I would call P1 or modified precision P1 because it's a unigram. It's you looking at the words independently. We can calculate modified precision on bigrams as well. And in that case, how would it do it? So bigrams in the machine translation, which is cat on the mat, or cat on the and the mat. So basically there are three bigrams. So cat on is a bigram, on the is a bigram, and the mat is a bigram. Okay? So again we do something similar. We count the number of times these bigrams appear in the machine translation. So this diagram appears once, this appears once, this appears once, and then the count of times uh, this diagram appears in the reference text. So in any one of the reference texts. So cat on appears once it appears in here, once it appears in here. So we'll say one. On the appears here, on the appears once here. So that would be one. The mat does not appear in the reference translation, so that's a 0. Then we sum these up. We say the 3 bigrams in the machine translation, 2 of them appear in the reference text. So modified precision in that case for the bigram is 2/3. See? So that's our modified precision P2. So I'll write it more formally. P1 was the sum of the counts of unigrams of a particular unigram in the unigrams generated by the machine translation, and I'll call this machine translation y hat, as we had said this is the predicted value, divided by the sum of unigrams in y hat and count of count of unigrams in. So this is the clipped version. Sorry, this is not in the, this is in the reference text. So the count of unigrams in here. So the precision for general n-gram okay, so this is this okay. So the sum of the count of this n-gram that appears from amongst the y hat it appears in the reference text divided by the sum of n-grams in y hat and the count of the n-grams. So basically we are calculating precisions at different levels. So we can calculate precision at the unigram level, precision at the bigram level, precision at the trigram level, and precision at the 4-gram level. So Blue Score actually combines these 4 precisions. What it does, it takes all 4. So precision of I, where I goes from 1 to 4, then it averages them. So average precision over the 4 precisions. Then it takes the exponent of this precision value and then multiplies it with something called a brevity penalty. Because you see the way Blue Score has been calculated is that if the translation is small, then it gets a high Blue Score. So that's why this brevity penalty is applied. Okay? If the translation is too small, we are going to apply a penalty to it. And the way this brevity penalty is calculated is such that this brevity penalty is 1.0 if machine translation length is greater than the reference length. So the references that we have, for example, the 2 references had length of 4 and this one also had 4 and machine translation also had a 4. So if machine translation length is greater than the reference length, then it's going to be a 1. Otherwise, it's going to be an, so let me write it as power of e to the power 1 minus reference length divided by machine translation length. Otherwise, so that means uh, if the length of the generated text is much smaller than the reference text, then we are going to apply this penalty, which is going to be a small number, and it's going to decrease the value of this blue score to normalize it. Okay? Otherwise, this is going to be the blue score. So this is where I'm going to stop for today, and thank you very much. I'll take any questions from here.